Good morning, everyone. Today, we are going to delve into the fascinating world of 3D graphics, focusing specifically on curve and surface design, lightning models, and ray tracing. So, the brief overview of the our today's topic is to the curve and surface design, lightning models, and ray tracing. In this presentation, we will delve into the fundamental concept of computer graphics, focusing on three vital components: curve and surface design, lightning models, and ray tracings. So, so starting to the our topic, we have to do some basics things. We might know the basic things. The computer graphics play a crucial role in various fields, including animation, gaming, architecture, and more. The realistic representation of object and scene is essential for creating immersive experience in virtual environment. Today's life we are almost experience in any devices, example mobiles, computers. They're very important role of the computer graphics in that. So let's get started. Without further ado, let's dive into the captivating world of curve and surface design, lighting models, and ray tracing. So first point is the curve and surface design. Curve and surface design is fundamental in the 3D graphics. It's art of creating smooth, visually pleasing object. Let's discuss a few methods. Curves. Curves in computer graphics are used to represent and design smooth shapes. Now we in daily life we use curves and many lines. So these are the curves. A curve is defined as a continuous mapping from an interval of the real number to a space. Example: Bezier curves, B-spline curves. So another point is surface. Surface are the natural extension of curve to two dimensionals. Surface are used to create 3D objects in computer graphics. Example: Bezier surface, B-spline surface. So there are so we are going to types. So the types in the curves is Bezier curves and B-spline curves. Bezier curves are basically defined by a set of control points. Example are quadratic Bezier curves and cubic Bezier curves. B-spline curves have smooth curve defined by a series of control points. Example: uniform B-spline, non-uniform B-spline. So Bezier curves are one of the most commonly used techniques. They are defined by control points and used to create smooth curves. There are two main types in Bezier curves: quadratic Bezier curves and cubic Bezier curves. So the quadratic Bezier curves defined by three control points. The formula for it: b of t 1 minus t raised to square p naught plus 2 1 minus t into p1 plus t square p2. Cubic Bezier curve defined by four control points and its formula is b of t 1 minus equals to 1 minus t cube p naught plus 3 1 minus t square t p1 plus 3 1 minus t into t square p2 plus t cube p3. So next is our surfaces. So not going to the surfaces, they are B-spline curves. B-spline curves are basic splines, are another widely used methods. They offer more flexibility than Bezier curves. There are also NURBS, non-uniform rational B-spline. NURBS are an extension of B-spline curve. They introduce the concept of weights, providing more control over the shapes. When it comes to the surface, we commonly use Bezier surface, B-spline surface, and NURBS surface. So Bezier surface are smooth surface defined by a set of control points. Example: quadratic Bezier surface and cubic Bezier surfaces. B-spline have a smooth surface defined by a series of control points. We have seen that one in the Bezier B-spline curves. Example: uniform B-spline, non-uniform B-spline. So next is their application. So application is the main role in a where is where it is used. So the first is computer aided design, CAD camera. Curves and surface plays vital role in designing objects in CAD software. When you are going in any field of engineering, you use the CAD software in graphics. The second one application is animation, using creating smooth character animation and visual effect. So in daily life we play the games, so their main important role of animation. If there is no animation, we cannot play the games. The third one is computer graphics, utilizing creating 3D models and shapes. Yeah. If we are going to in 2D, so there is much more flexible and realistic in 3D. So next our is these are the images of Bezier curves, Bezier surface, spline curve, Coons curve, seen that the smooth lines, points. So our next topic is lighting models. Lighting models are crucial in 3D graphics. They simulate how light interact with surfaces, adding realism to the scenes. So the basic is what is lighting in computer graphics. Lighting is the process of simulating the interaction of light with objects in a scene. So take an example of a camera. If we click a photo, it it can be a very realistic. So if we remove the light from the camera, so we cannot click the photo. So these are the lightning. Why lightning models are important? Lightning adds realism to the computer generated image. So next topic is our types of lightning models. So local illumination models, Lambertian reflectance model, assume the light is reflected equally on the all direction. It is a Lambertian reflectance model. Phong Reflection Model, it is consider the specular reflection along with the diffuse reflection. So there are also many types: ambient lightning, diffuse lightning, specular lightning. So we are going to the next so the global illumination model, ray tracing and radiosity, more realistic simulation of lightning, traces the path of light rays through the pixel in an image plane. So the it traces the one by one of all pixel. Radiosity simultaneous the way surface reflect light. So their application is, so we are not going to the directly on the application. You're seeing the one, another types of the lighting model, Phong reflection model. The Phong reflection model calculates the color of a point on the surface of an object. It has three components: ambient reflection, diffuse reflection, and specular reflection. So the application of its computer games. Sorry for this. Realistic lighting makes the gaming experience more immersive. Now there are many gaming zones in that we are experience the uh, virtual games. So there is a application of it. Movies and animation, essential for creating realistic scenes. We all see the movies, animation movies. Okay, the architectural visualization provides a realistic view of architectural designs before construction. So next topic is our ray tracing. What is ray tracing? Definition. So ray tracing is basically rendering techniques used to generate an image by tracing the path of light as a pixel in an image plane. So history of it introduced by Arthur Appel in 1968 and further developed by Turner Whitted in 1980. So ray tracing is basically a rendering technique that simulates the way a ray of light interact with object in 3D scene. It produces highly realistic lighting effect. When we all know that we have experience in the many of the videos. So there is a application of ray tracing. So next is the ray tracing process. So the process consists of the some steps. So we see that steps: ray generation first, shoot a array through the each pixel of the image plane, means it's check the one by one pixel. So second is intersection, determine if the array interact with an object in the scene. Third one is shading, calculate the color of the intersection point. Fourth one is reflection and refraction, simulates reflection and refraction. And the fifth one and final stage, final image, compose the final image from the calculated rays. So components of ray tracing. So the ray generation, first we have to generate the ray. Of course, ray are cast from the eye through each pixel in the image plane. Second one, intersection, determine where the ray intersect with object in the scene. Shading, calculate the color intensity of light at the point of intersection. This is the main is intensity. If we are low intensity, so we cannot see the clear picture. So the high intensity means quality picture. Reflection and refraction. Rays can reflect or refract when they hit certain surface. We have seen that reflection meaning and refraction meaning. So we are not going to further deep. Rendering the image, combining the above steps to generate the final image. We are, these are the same as the we see in the steps. So the application. So don't go to the application. We see the advantages. So the first is realism. Ray tracing produce highly realistic image. As as we see, versatility. It can simulate various lighting condition accurately. And third one is shadow and reflection. Ray tracing accurately handles shadows and reflection. Yeah. So the application is a movie industry using creating special effects in movie and animation. Gaming, using high-end gaming to provide realistic visuals. Now there is a one game known as a Horza Horizon. In that we are controlling the cars virtually. There are the setups, so we you can play. Okay, architecture visualization helps architecture visualize building and structures before construction. So we can design by our basically is generates all the 3D effects virtual. We so before the building is built, we can see the all the what be the our outcome in this. Uh, okay, so the conclusion is today we explore the three critical aspect: curve and surface design. In that we see in Bezier curves, B-spline curves, and NURBS. Lightning models, ambient, diffuse, specular lighting with a focus on the Phong Reflection Model, ray tracing, a rendering technique to generate realistic image. So next one is our conclusion. Recap the main points cover. Emphasize the importance of curve and surface design, lightning models, and ray tracing in computer graphics, future developments, and potential applications. So the thank you for joining me. I hope this session has provided valuable insight into the fascinating world of 3D graphics. So now I'll be happy to take any questions you might have. So thank you.